We are now going on to part 3 of the parts of the computer. We're looking at the motherboard. The computer's motherboard is a large printed circuit board that physically connects all the different components. Now we're looking at, there are specific positions where your CPU, GPU, and RAM can be inserted. You have slots for RAM. There you have your CPU slot, which fits into a ZIF socket, zero insertion force socket. Then we have slots for your GPU, which is for your graphics processing. Connectors that allow you to connect a power supply to your computer. So we need to be able to also connect the power supply, so the components that are connected to the motherboard will get power. There are ports that allow you to plug in devices. So you plug in devices through the ports, such as your keyboard, speakers, monitors easily. So these are the different parts of your motherboard. Now the function of the motherboard is to provide a place for all devices or interfaces to be connected, such as more memory, can add more RAM or other graphics cards. The function is also to distribute power to the various components. So a motherboard provides a place for devices to be connected, or different components to be connected. It allows the distribution of power. It also acts as a communication hub, as the components send and receive information to the motherboard. So information, for example, between RAM and your CPU travels to the motherboard. So motherboard acts as a communication hub. Your processing devices, that's your CPU. Processing devices are responsible for carrying out instructions and performing calculations. One is your CPU and the other one is your graphics, your GPU. This is your central processing unit. That's your graphical processing unit. Now, in terms of your central processing unit, it's located inside the computer case on the motherboard. It's responsible for receiving and carrying out computer instructions. Each CPU can be made up of multiple cores that are independent processing units that can complete tasks on their own. So a CPU can have multiple cores. The CPU can have multiple cores. This allows for what we call multi-threading and multi-processing, which we'll discuss later on. So the CPU allows, because of the multiple cores, if it has multiple cores, it allows independent processing by each unit. As a result, multi-threading and multi-processing. By adding multiple cores to CPU, the processing power available to the computer can increase dramatically with little heat gain. These types of processors are called multi-core processors. The CPU contains a control unit that coordinates all activities in the CPU. So your control unit coordinates all activities in the CPU, and your arithmetic logic unit, your ALU, where the logical operations and arithmetic calculations can be carried out. So for logical operations and arithmetic calculations is your ALU, arithmetic logic unit. And your control unit coordinates the activities on the in the CPU. Now your graphics processing unit is located on plug-in cards, as your graphics card on the motherboard. Or it can be on the same chip as the CPU. So your graphics processing unit, you can purchase it separately. It comes with a graphics card, or it can be on the same chip as the CPU. It is responsible for creating and doing the calculations needed to display images on the screen. By having a good GPU, it reduces the load of the CPU, so your CPU can run other instructions, so allowing your computer to work faster. So your GPU is focused on the processing of the graphics of the images. Now your ports, the following are some of the most important ports on the motherboard. Your USB. Your USB is a common port, and most input and output devices like a flash disk and smartphones can connect to the motherboard using a USB. And the purpose is to transfer data and instructions to and from your computer. So you can copy to the computer or from your computer onto a USB device. Your HDMI is for connection of monitors, projectors, television, speakers, designed to transmit high definition audio and video signals. So HDMI works with high definition transmission. Speakers, earphones, and microphones. The port name is 3,5 mm. Is to enable these devices to produce sound. Right, so these are for your speakers, earphones, and microphones. Your Ethernet, that's for your network. A UTP cable with RJ45 plugs into your Ethernet port. So your network cable, your UTP unshielded twisted pair cable with an RJ45 plug at the end of the cable that looks very much like your telephone line. It connects into an Ethernet port. Ethernet port allows motherboards to connect to a wired network and to send and receive data within the network. So Ethernet port is for connecting to a network. The Thunderbolt port is used to connect to high-speed devices connect high-speed devices to your motherboard. Right, so your Thunderbolt port is a very fast port for high-speed devices. It allows the transfer of data to and from the device. Now we're looking at your memory. This is your RAM. RAM is a physical hardware that temporarily saves data. Remember, RAM is volatile. So whatever is stored in RAM can be lost. It serves as a computer's working memory. So data and instructions you're working with currently will be stored in RAM. RAM provides space for your computer to read and write data to be accessed by the CPU. So your CPU and RAM work closely, and RAM stores the data you are working with. RAM is volatile meaning that data is lost once electricity is disconnected or the power is lost. Now, memory versus storage. RAM is used to store applications and data that the CPU is working with. Storage, like your hard disk drive, your solid state drive, and your flash drive, permanently stores apps, data, and completed work. So when you save your work, it gets stored on a hard disk drive, depending on the drive that you have. But that's your secondary storage. RAM is your primary storage. So when you save work, it goes onto your secondary storage, which could be your hard disk drive, solid state drive, or your flash drive. And it's permanent storage. The activity thus far on your motherboard is in your DBA textbook, page 81, activity 3.4. We're going to move on to comparing a computer to a mobile device. Now, when you're comparing your computer, like your desktop, to a smartphone, in terms of keyboard, this is a full-size keyboard. This keyboard is smaller. So it's easier to type on a desktop versus a smartphone. Your mouse, your desktop has a mouse, touchpad. It can have a touch screen, a stylus. But your smartphone is restricted to a touch screen and a stylus. Computers allow more accurate input using a mouse. Smartphone has to rely on a touch screen for input. A stylus can be used with a touch screen to improve the accuracy. So instead of using your finger on the touch screen, you can use a stylus to improve accuracy. Cameras, desktop has to be purchased, but in a smartphone, it's built in. And remember, smartphones some of them have high quality cameras, allowing you to make video calls and take videos and photos. The microphone, again, on a standard desktop, you got to purchase it, but it's built in your smartphone. So you can do recording on your smartphones, and allows you to make calls on your smartphones. If you're making a WhatsApp call, then you need a microphone. Your biometric device, you've got to purchase one on a desktop. It's built in most recent models of smartphones. Many high-end smartphones are released with fingerprint readers, retina scanners, or face identification. These items are expensive additional purchases on computers. So desktops have larger output devices that are easy to use, but smartphones often have very high quality output devices. So desktop has larger devices output, but the smartphones have better quality and smaller devices. If you look at your monitors, desktop is between 19-inch and 34-inch. Your smartphone is 3-inch and 6-inch. So when you're viewing your apps, you have a larger space in terms of monitor size to view the apps. Clearly, smartphone is restricted in size. but the small monitors or smartphones have a higher resolution. So they have a very good quality or high quality image compared to your monitors. In terms of speakers, desktop you need to buy or purchase. Smartphones have them built in. But while smartphones have built-in speakers, the quality is low because of the limited space of smartphones. In terms of internal storage, desktops may have a hard disk drive or a solid state drive, but smartphones have very small built-in NAND chips. So desktop computers are significantly better in terms of storage. The average desktop computer has almost 40 times more storage space than a smartphone. So for smartphone, we need to purchase extra storage. For desktop, you can also purchase external storage as well as your smartphone. External storage can be purchased for both of them, the desktop and the smartphone, although it is more affordable for desktops. Some smartphones do not allow you to add additional storage. So it all depends on your smartphone. You can have an SD card for additional storage. Your CD, DVD, they're built in. If they're not, you can purchase and add extra. But your smartphone, you need to purchase. While it is possible to purchase a CD, DVD reader for some brands of smartphones, it is expensive and not easy to use. So it's not something that you would do often. So although it is possible, it is expensive and it's not easy to use. Desktop computers are more powerful than smartphones in processing power. So if you're thinking about your processing, your desktops have a larger space for your CPU and it has more space for RAM, internal memory, so your processing power is higher than smartphones. High-end smartphones have power to perform tasks quickly and efficiently, but there are many processing-intensive tasks that cannot run on smartphones. These include complex mathematical simulations, video editing, or rendering, and certain games. So you can see the limitation of smartphones in terms of games that you can play, the amount of video editing that you can do. They all have limitations on your smartphone. Your CPU on your desktop and smartphone are both built in. Even though smartphone processors can be very fast, they're still considerably slower than your desktop processors. And these are also easily upgradable or replaceable with a faster version. So you can replace the faster version, but a desktop CPU will be faster than your smartphone. Your graphics processing unit is built in. You can also purchase an extra graphics card with the GPU. Your smartphone is built in. All right, so your built-in GPUs are much faster on your desktop than your smartphone GPUs. And you can also buy a faster GPU for your desktop. So this is a better option in terms of your GPU. And RAM is built in for both. Remember, there's more space on a desktop for more RAM. So with high-end smartphones, you can have the same amount of RAM as average desktops. But the RAM will be a lot slower than the general desktop RAM. So your desktop RAM is faster and allows you to add more RAM. Smartphones are generally designed to be used on their own without any additional devices. So they have fewer ports. So it's making it harder to connect smartphones to other devices like your speakers or monitors. Smartphones have all the important devices built into them, including a wide variety of communication devices. You can connect wirelessly easily with a smartphone. Your motherboard, both these are built in. So remember, the desktop can have a larger motherboard. Your communication, here you can have your Ethernet port. You can connect to a network cable. Your smartphone allows connectivity anywhere and everywhere because you carry it around with you, and it has Wi-Fi, Bluetooth, NFC, near field communication. This allows easy communication. So in terms of networking, smartphone allows easy connectivity. In terms of ports, your desktop has many different ports, but your smartphone as less ports, like a USB and then your port for your phones, your headphones, and a docking station. Right, your activity is from your DBE textbook, page 85 and page 86. Right, this is the end of hardware. Our next section will be on software.